We begin by stating the problem clearly. Imagine a rectangle. Inside this rectangle, we place two identical circles sitting side by side. Each circle touches the top and the bottom edges of the rectangle. The left circle touches the left vertical side of the rectangle, and the right circle touches the right vertical side. The two circles touch each other exactly in the middle. Our task is to find the area of the region inside the rectangle that is not covered by the two circles. Now, step 1. Let us define the radius of each circle. We will call it small r. Congruent means both circles have exactly the same radius. Small r is the distance from the center of a circle to its circumference. Since both circles are identical, everything we calculate will depend only on this one variable, small r. Step 2. Look at the vertical dimension of the rectangle. Each circle fits exactly between the top and the bottom edges. That means the diameter of a circle equals the height of the rectangle, and diameter is simply 2 times the radius. Therefore, we can say in words, height equals 2r. Say it again. The rectangle's height is equal to 2r. This comes from the fact that the circle touches both the top and bottom edges. Step 3. Now let us examine the horizontal direction. The rectangle holds two circles placed side by side. Each circle has diameter equal to 2r. When we place them next to each other, the total width is 2r plus another 2r, which equals 4r. So the rectangle's width equals 4r. Notice how the tangency conditions make this precise. The left circle touches the left wall, the right circle touches the right wall, and they meet in the middle. Step 4. With both width and height known, we can compute the rectangle's area. The area of a rectangle is width multiplied by height. Substituting width equals 4r and height equals 2r, so rectangle area equals 4r times 2r. Multiplying gives 8r squared. State it clearly. Rectangle area equals 8r squared. Step 5. Next, compute the total area of the two circles. The formula for the area of one circle is pi times r squared. Since we have two congruent circles, the combined area is 2 times pi times r squared. Repeat. Total circle's area equals 2 times pi times r squared. Step 6. To find the uncovered region, subtract the total circle area from the rectangle area. So uncovered area equals rectangle area minus circle area. Substituting the expressions, that is 8r squared minus 2 times pi times r squared. Say it once more slowly. Uncovered area equals 8r squared minus 2 pi r squared. This expression can also be factored. Factor out r squared and we get uncovered area equal. Step 7. Let us check the formula with simple numbers. First, suppose r equals 1. Then, rectangle area equals 8. Circle area equals 2 times pi, about 6.28. Subtracting gives 1.72. That matches the factor form because 8 minus 2 pi is about 1.72. Now suppose r equals 2. Then rectangle area equals 8 times 4, which is 32. Circle area equals 2 times pi times 4, which is about 25.1. Subtracting gives about 6.9. Again, this matches the formula since open parentheses 8 minus 2 pi close parenthesis is about 1.72 and times r squared, which is 4, gives about 6.9. These examples confirm our result works perfectly. Step 8. To finish, let us summarize clearly. The uncovered area is equal to open parentheses 8 minus 2 pi close parenthesis times r squared. This tells us the empty space grows with the square of the radius. The constant factor, 8 minus 2 pi, is approximately 1.72. That means the empty space is always about 1.72 times r squared. In plain language, as the circles get larger, both the filled space and the empty space scale with r squared, so the formula remains valid for any circle size. And that completes the solution. subscribe, like, share. See you next video. Bye.